How to check if two indices in different NumPy views point to the same memory. Understanding memory sharing between indices in NumPy views. When working with NumPy arrays, especially views created through slicing or advanced strides, one common question is: how can I determine if two distinct indices in different views of the same base array point to the same underlying memory? This is particularly important when implementing operations like custom gradients, where counting contributions from overlapping elements must avoid duplication. The problem: overlapping memory in strided views. Suppose you start with an array n of shape h, w, and create a view using sliding windows with strides. This view strided _ n organizes windows over n when computing gradients or aggregations like backpropagating gradients requires mapping each output gradient element back to all original entries of n that influenced it. The challenge is, because of repeated values and overlapping windows, blindly matching values, example np.max, block, == n, i.e.j, leads to overcounting contributions. You want to know if n, I, j, and strided _ n, m, n, x, y actually refer to the same memory address to count contributions precisely. Why np.shares _memory isn't enough. np.shares _memory, ARR1, ARR2, checks if two arrays share any underlying memory but does not determine if specific elements correspond. There is no built-in NumPy function to directly check if two scalar indices in different views reference the exact same data location. The practical approach, using __array interface _ in strides. Every NumPy array exposes a _array interface _ dictionary with critical memory layout details. Data, a tuple where the first element is the memory address of the underlying data buffer. Shape, the array shape. Strides, the byte-size steps to move along each axis. Key insight: two indices correspond to the same memory if they resolve to the same absolute byte offset within the base data buffer. Step by step. Get the base data pointer. Calculate absolute offsets for both indices, for an array ARR with strides ARR strides and index IDX. Compare the addresses. If the addresses are equal, the indices point to the same memory location. Example. For example, if ARR1 is shape 2 and ARR2 a view shape 2, 1, computing the address of ARR1, 0, and ARR2, 1, 0, will help decide if they share that specific memory. Notes and cautions. This works reliably for contiguous data types with fixed byte size elements. Fancy indexing or copies break this approach, as memory may not be shared. This method involves low-level memory arithmetic and assumes you can access .strides and _array interface _. Summary. NumPy does not provide a direct function to check if two scalar indices in different views point to the same memory. You can manually compute their underlying byte addresses using the array's base pointer via _array interface _ data 0. The strides and indices. Comparing computed memory addresses tells if the elements overlap in memory. This technique enables accurate gradient propagation and other advanced operations on overlapping windows or strided views.